Assalamualaikum and good morning everyone. My name is Muhammad Aziz Azlami bin Mokhtar. My metric number is B1324102441. Today I would like to present our laboratory experiment entitled Introduction to Belt Fission for the subject Basic Tribology BMKM 2323. This experiment studies the frictional force generated between a belt and a pulley during motion. Belt friction is important because it allows powers and torque to be transmitted without slipping. We investigate how the angle of contact and the belt material affect the belt tension and coefficient of friction.
For the objective, first, to determine the relationship between belt tension F1 and F2 and the pulley during motion. Second, to study the effect of friction in types of belt surface such as leather, hem and rubber belts. And lastly, to understand the surface characteristic for each type of belt.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fakar Kamal bin Abu Sama. Matrix number B13240219. So I will continue for our presentation. I will continue for the methodology of the experiment, which consists of two parts. Experiment 1, the effect of contact, and experiment 2, the effect of different belt materials. So first, for the experiment 1, which investigates the effect of act of contact or belt tension. So the pulley was adjusted to set the initial tension F1 to 15 Newton. So the pulley was rotated in anti-clockwise direction at contact speed. And then the values F1 and F2 were recorded. So after the initial data were collected, the clamping lever and the support was adjusted to change the arc of contact. A swivel type belt holder was adjusted to set desired contact angle, where each pin interval represents 15 degrees. So the experiment was first conducted at angle 150 degrees. The initial tension was reset to 50 Newton, and the pulley was rotated again while recording the values of F1 and F2. This procedure was repeated for an angle of 120 degrees, 19 degrees, 60 degrees and 30 degrees. The purpose of the experiment was to observe how changing the contact angle affect the frictional force between the belt and the pulley. For experiment 2, the objective was to investigate the effect of different belt materials. Three belts were tested, which is hem belts, rubber belts and leather belts. So for each belt, the act of contact was fixed at 180 degrees and the initial tension was set to 50 Newton. The pulley was rotated at the constant speed and the values of F1 and F2 were recorded. The same procedures was repeated for all three belt materials to compare their frictional performance. For the conclusion in methodology, experiment 1 examined the influence the act of contact on belt friction, while experiment 2 compared the frictional performance of different belt materials. So the recorded values of F1 and F2 were then used for the further analysis to determine the relationship between contact angle, belt material and the frictional behavior.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fazri Azim bin Sudin. My metric number is B1324102213. So okay, now let me share with you what we found from our experiment. We did two experiments, so let me explain the results one by one. For experiment 1, we look at how the angle of contact between the belt and the pulley affects the tension ratio. That's the ratio of F1 over F2, where F1 is the right side and F2 is the slack side. What we found is the bigger the angle, the higher the ratio. So when the belt wraps more around the pulley, the friction increase and the belt can hold more force without slipping. This match exactly with a formula called the Caxton equation, which predicts this kind of relationship. So our experimental results confirm the theory. So for the experiment 2, we test three different types of belts, which is leather, hem and rubber, all against a grey cast iron pulley. After comparing the results, the order of friction coefficient from highest to lowest is leather 0.937, rubber 0.441 and hem 0.256. So leather has the highest friction, meaning it grips the pulley the best. This also means leather can transmit more power and is less likely to slip. Now, interestingly, the hem belt gave results that were closest to the textbook values, while the leather and rubber belts had bigger difference from what the theory predict. This could be due to surface inconsistencies or slight experimental errors during testing. So in summary, a larger contact angle and a high friction coefficient both help the belt perform better. That's the main takeaway from our results.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz. Today I would like to present about conclusion. Okay, the experiment confirmed the characteristic equation by comparing the measure and calculate ratio F1 over F2 for different angles of contact. This showed that the angle of contact can change the material friction coefficient. The measure ratios were very close to the calculate ratios, with only small difference at higher angles. This difference were caused by mistake in the experiment, change in friction, change in the material, and theoretical assumptions. That's all from my group. Thank you.